Ladies and gentlemen, let us give another big round of applause for our speakers in the first session and also Ms. Rista Anggraini. And without further ado, let us now proceed to the next plenary session in which I myself will moderate. And so allow me to officially welcome you to the second plenary session. And here we have with us our three international speakers. Yeah, the first one is Dr. Juris Burlakovs from Estonia. Good morning from Indonesia, Dr. Juris Burlakovs.
Good morning.
Morning, how are you?
It's very early here.
Very early there. What time is it then?
It's 6:27 now, but I'm more than an hour here.
Thank you for waking up early for us. Okay, and our second speaker is Dr. Zain Vinzavika Gale from Latvia. Good morning from Indonesia, Dr. Zain.
Good morning.
Morning, how are you, Dr. Zain?
I am fine. So I will try to understand what I have to push.
Okay. Okay.
Okay. Can you see me? Okay. Oh, I'm on my phone, so it's not so easy. Hello to all. Nice to meet you here, and so I will be glad to present after Juris.
Okay, thank you very much for joining us in this conference. And our third speaker is Dr. Heni Sukorini from UMM Indonesia. Good morning, Bu Heni.
Morning. Can you hear my voice?
Yes, but
yeah,
it's
okay.
quite faint, Bu. Lirih sekali. Oke, sehat Bu Heni ya?
Ya, alhamdulillah.
Okay, thank you for joining us and willing to share your expertise with us. Now, giving the first talk in this second plenary session is Dr. Juris Burlakovs. And he will talk about the advanced studies of inert landfill fine fraction mass, hunting for values from waste. But before we move on to the talk, let me introduce him shortly. Yeah, Dr. Juris Burlakovs is currently serving as extraordinary researcher in the Estonian University of Life Sciences. He obtained his PhD in life science in 2015, and he has extensively conducted research and published in the area of biosciences and environment, environmental protection, environmental technology, and pollution control. Ladies and gentlemen, please welcome Dr. Juris Burlakovs.
Yes, I can try to share my screen now. Hope that I will find, because I don't know how. I'm not sure that I'm very good at Zoom, how to find this, because it doesn't offer the from the computer anything.
It's the green share screen button.
Share screen, but where to get the? Okay, I need to open it first. Understood.
Yeah. Understood. It's usually at the bottom. Or do you want us to share?
I open it now soon. Wait a second.
Tidak, filenya ada di pas galip
You
atau
can
di
also help sharing the screen.
I think I have it now, right?
Yeah. Yeah. Okay, we can see your screen now.
How to make it as a presentation now is a good question. F5 is not working.
Oh, it's the slideshow at the bottom too. At the bottom right.
This one.
Yeah. Ready.
Oh, selamat siang to you. So I think it's afternoon already. Tere päevast, it's like daytime here in Estonia. And I have advanced studies of inert landfill fine fraction mass, hunting for values from waste. Sounds very difficult, but actually it's very easy. What can we get from the waste we don't use anymore, but not from the garbage big one, but from the small particles, which usually is the inert part, like a land looks like. I am together with several people. You also see the Professor Zane Vincevic-Gaile, which will be the next presenter. And we simultaneously work on different projects and help each other in some way. And also we are working together with Roy and Rocco from Indonesia for a couple of years. And you see other authors also from Estonia and Latvia. Just shortly introduce the problem. The problem is that we have the growing rate of like waste electronic equipment and other wastes which can contain very valuable particles like rare earths and platinum group metals. And in European Union, and not only in European Union, we have problem with these strategic resources. And our point is to try to find the technological potential for high metal recoveries by using different means, starting from the large sorting, if you take the big ones, and for the fine particles, you need to use and try some experimental hydrometallurgical bioleaching and other approaches. Why do we need this? We have the critical raw materials for the European Union. European Commission Enterprise and Industry section has developed like pillars, what we need to do. The main challenges is that the EU is highly dependent on imports of raw materials, metals, industrial minerals, which are increasingly affected by market distortions. We have seen like in 2011 when China put the ban on rare earth, for example, and in 1 hour some metals raised in price like 100 times even. Here are just you see the curves, how fast can change the price for palladium and comparably to the economical indices. And this raw materials initiative is in 3 pillars. It's based on it, ensuring access to raw materials from international markets. You see the problems now in pandemic also with the supply chains. And for the industry, you know that the problem is with these microchips for computers. Also, so America doesn't know what to do, and other countries. So you have the shortage, and price goes up, inflation goes up, and no one is happy at the time. The another pillar is right framework conditions within the European Union. So it means that we need to think about own resources. And the third one is the resource efficiency and recycling, which we here think about. Is of course we need to reduce the consumption if it's possible of primary resources, and then we can think about the recycling. There are some pictures from Australia. You see the road train of 200 tons every 5 minutes from Australia goes to port, and then it goes to China, and China is the largest producer. And in Europe, the idea is we need to take away a little bit of this narcotical dependence of the Asian markets. It's not my idea, it's European Union idea. So to increase resource efficiency, the Commission published a roadmap on how to move towards efficient Europe. And this roadmap exists already from 2011, but as far as you have heard, perhaps we have a lot of countries in the European Union, and this process is not so fast. So the perspective is up to 2050 in the best way. What are these critical raw materials? Critical raw materials are of great economic importance with large supply risks, and a lot of environmental possible impact. I mentioned already this electronic waste, and like all these things can be coupled in these 3 points. Just to mention what are these critical minerals, critical elements, you see, probably you have heard about that. You have a lot of use in the renewable energy for solar cells, wind turbines, for hybrid cars, LED lighting, batteries, flat screens, everything you can imagine in the newly developed technological revolution now. So here are a lot of numbers, but the main is that the productions must be raised. The substitution is needed because a lot of these minerals like antimony, for example, are already finishing for the resources. So we need to think about how to recycle better. So here you see what 4 different raw materials are used for, like platinum for fuel cells, catalysts, palladium catalysts, and seawater desalination. So you see that emerging technologies which are growing in the world need these elements. High supply risks, a lot of worldwide production, like from China, geopolitically unstable countries like Congo, we can call also Russia a little bit unstable in some way, Brazil, and some of these elements are really from just a few countries, and it means that the supply risk is too high. We need to think how to manage that. Low substitutability, what does it mean? It means that there is no alternative at the moment, like from rare earths and for platinum group elements. And low recycling rates. They are used in very low concentrations in electronics, for example, or for renewable technologies, aerospace industry, and you cannot recycle. So what you dig out, you use, and you cannot get back. Here is the ranking according to the environmental country risk. And you see that rare earth is one of the biggest. Then you see antimony, germanium, platinum group elements, tungsten, and other elements. So to the right side are with the greater risk to pollute the environment. Another diagram for the supply risk combined with economic importance. And you see again that rare earths and platinum group elements are in the upper right part. And then you see also germanium, indium for telephones, cobalt for different electronic industries, and so on. So just if you know Mendeley table by visual better, then you see where there's located in Mendeley table these elements. And the rare earth element is this usually green line in Mendeley table with the they are actually not so rare. They are with very similar chemical properties, so it's not easy to distinct each from another one. So you dig out together with another polymetals, and then it's very hard and contaminated process, like in Inner Mongolia, in China territory, you have big quarries like Bayan Obo, and this environmental risk is very high. So we need to think how to try to recycle. So this critical list is updated every 5 years, and carried out further studies, competition to land use, cradle to grave, LCA, like life cycle analysis. And in European Union is established a subgroup of raw materials supply group on criticality, this specific problem. Again, just a visual description how the world metal prices are changing. They are not stable, and usually I have seen in lectures that everyone is telling that prices are raising all the time. It's not entirely perfectly true. It's these prices are fluctuating, but this volatility is not good for economy as well. If it would be constantly raised and you print the money, so then it would be better than it's just volatile like that. And for tiny markets, you see these cubic type of curves, like for osmium or several other metals which are used by just a few companies in the world. This price one day can be very small, and then next day it can be 1,000 times, because there is no alternative, as I mentioned, for some of them. Here I visited Australia for the Commodity and Stock Exchange Center to study a little bit about the pricing. Just a short outlook about the financial crisis. Why are they occurring? Why are damaging economy? And this is perfectly linked to is the commodity super cycles. And nowadays we are like in commodity super cycle, which drives the prices up. If we get the rock bottom last year in March when the pandemic started, now the prices have doubled and tripled and multiplied for different elements. Here is just a description how the platinum group elements look like in nature in the pure form. Platinum group elements' role as critical elements for industry in future will rise, requiring sustainable exploration, mining, and recycling in frame of circular economy. And here we need, first of all, in my opinion, my humble opinion, is to develop the markets for recycled material. And this is where we work in environmental economics part, because we have tons and millions of tons of waste, and a lot of this waste is not even tried to be recycled as these inert masses from the landfills. In Europe, preliminary findings have shown that a lot of these, I would say, good for commodity dig out places are actually taken up. No one wants these mining in their backyards, and you see like tungsten in Spain or some fluorspot in the middle of Europe. They are built over the cities, and there are natural parks and other difficult things, so you cannot use them actually. You have these mining places potential, but no one ever will use it in the next century perhaps. Just to mention a few approaches, you can use the hydrometallurgy, you can use leaching by bacteria to try to get out the specific elements you need. Absorption, compactation, precipitation, electrowinning, and to select these strategies, actually the innovation should be put, and also the markets should be changed in some way by the governments perhaps. No one in industry likes the Green Deal per se, except the renewable technology people, of course. But the fact is that these prices will be up, and the taxes on environment will be raised. So it means that a lot of incompetitive strategies can be competitive in the future. So I try to explain it in an objective way, not from the green person way, but just that it is the fact, and it will be like that in the future. So, the short little bit. The problem is how to raise from the lab scale to the full scale applications. There are some pilot applications from Hydrover Relight plant in Milano, and Umicore in Belgium, and some from Rare Earth actually is American company in Estonia, in a small country I'm now here working. And I have participated also as the member in Cost Action, which is like networking of scientists for recovery of waste electronics. It's a very difficult topic. Important research dimensions for the future is better characterization of treated electronic waste. All the waste contains electronic waste, whether it's from from old landfills, or whether it's from the inert mass where everything is mixed up. It depends what is the concentration. Of course, it is influencing if it is feasible to get them out. Then it's optimal pretreatment strategy, which I personally work most of all, because we work together with waste management companies. And then to go to demonstration plant and existing EU projects, it's a long way to go. One of co-author, Ruta, you saw in the first slide, works on clay sorbents, and we try to use also from the wastewater, not only from the solid waste, but also from the leached material. So we tried some sorption experiments for rare earths, lanthanum, cerium, neodymium. You see the sorption curves, and clay sorbents work very well. The question is how to drive up it from experimental stage to the bigger. Already 5 years ago, one of my colleagues in Estonia, Professor Kripsalu, presented about metals and rare earth elements in landfills, some case studies, and several landfills were studied in Estonia, Sweden, and Latvia. You see the map. The Baltic Sea is a little bit smaller than Yellow Sea if you compare with your region, perhaps. And you see our region, where it's located. We chose the different places to see how the landfills are. They are never the same. Every landfill is individuality. Here, for example, is the port area, which actually is contaminated site in many places. So you have a lot of these dissolved, interesting for us, materials, minerals. We did some simple drilling. It's the historical industrial waste soil. And, just if to calculate the approximation, we have some kind of 1.5 to 2 megatons of these elements which you see, and remediation project is still waiting its order because the government doesn't have in Latvia money for that. Easier to get it monitored and buried under the soil. The aim of this study was to determine the elemental content of this inner part, which is bound in colloidal form with silky aggregates from excavated soil, to assess recovery potential of different metals and rare earths for the future. So why rare earths? I already mentioned they were not primary objective. Primary objective in this project was the remediation, but it is like extra. Rare earths can have strategic and expensive, up to several $1,000s per kilogram, and for European, for example, it can be even higher. It's useful to know what do we do with this, let's call it stock for the future. If we go for extracting of major metals from contaminated site or from the landfill, perhaps we can, in some way, to use innovation, and whether it's rare earths or platinum group elements or something else. So we can try these mentioned before technologies. I already mentioned in Estonia this company, Molycorp from United States. It is already producing tantalum and niobium from loporite ores, but they are importing it from the Kola Peninsula in Russia anyway. But they are interested in the results of these innovative future technologies. So the aim is to find sustainable resources recovery potential for fine fraction of landfill waste with several objectives: to estimate recovery perspectives, to investigate interactions among remnant pollution and organic matter, because it's very hard to divide from organic matter. This is the challenge. And provide scientifically approved recommendations, not only from recovery, but also for the ecosystem revitalization in landfills. Because if the landfill must be closed according to the rules, maybe we can get some extra bonus with the materials out of it in circular economy perspective. So Just a few words again about the problem. The prices of minerals go up, in general go up with fluctuations. And global demand will double next 25 years, especially for these specific critical elements, because we have technological revolution now. And the possible answer is to take even the old landfills and use the landfill mining approach. So to excavate from historically dumped waste, this is already the innovation, reducing the greenhouse gas emissions by taking away the methane, and we restore the landscape. We can get the park in it, for example. This is a completely new market which we can go to. Just a speculative calculation for 3 small Baltic states, we have 1,700 closed landfills. We can get 2 million tons of refuse-derived fuel for energy, 0.33 million tons of metals, and 140 tons of rare earths. It's very theoretical, of course, you understand it, but it's just to show the numbers. It can be up to, just from Latvia, it can be like 100 million theoretical euros. You see the materials by type. We analyzed many tons of the waste to see what's inside of the teddy bear. You see that some of it is plastic, and this others, this more than 1 million tons of weight is the inert waste, actually, these small particles which no one actually does so far. So if we find a way, so it's a good challenge and good perspective for that. Will not go in detail about the methane degradation, but also the challenge is the greenhouse gas effects. We are working now of innovative capping of this inert waste material, if we can take not only the minerals out of it, but also to use it for the degradation of methane, which is going out from the landfills. You close the landfills and cover it with specific material from the inert waste. So the master plan in our case study was to develop from the existing landfill the capping, which destroys the methane, and make a park in this landfill.
Dr. Juris, excuse me, can we finish in maybe 1 or 2 minutes?
Yes, it's almost the end. Therefore, I skip very fast. So you see that not only the minerals out of the landfill, but also we get the greenhouse gas effects. And just the pictures how it's in the beginning, the work, and then we measure the methane. So you see that it's good for environment, society, and economy. So we need to go to the spaceship economy, and it is like 2 questions: is the Earth open or closed? We need to have this circular approach, and the same we need in economic system. We don't have it yet, especially after the pandemic. Everyone is talking about the growing of the linear economy per se. And this already I mentioned. Future of landfills is logistic centers for recycled material, industrial thematic parks, and possibly also we will have critical elements out of this. So you see that it's multi-scale thinking needed here, and teamwork is very important. So thank you very much.
Thank you very much, Dr. Juris Burlakovs. Give a big round of applause for him, Bapak Ibu. So, okay, so Dr. Juris Burlakovs has given a very insightful talk about how the critical state of raw materials inert landfill can serve as one of the solutions, yeah, especially for the inner economy. Now, I think it's a very important topic for Indonesia and also for many other countries all over the world. And now I think I've seen that there are questions already in the chat room, if you can check, I think we can go to the question from Pak Roy. Yeah, I think we can directly take some question and answer it directly. Is that okay, Dr. Burlakovs, Dr. Juris Burlakovs? Yeah. So the question here is, if you can see in the chat, you are an expert in heavy metals, and in Indonesia, 15 years ago, a disaster called Lapindo Brantas, if you are aware about it. Yeah, it happened. It's the mud that came out of the ground and covered about 16 villages in 3 sub-districts in Indonesia. And there were many issues which results in the statement that this mud, it contains a lot of heavy metals and also rare metals too. Now, can we work together, maybe using your laboratory in Latvia and Estonia?
Yes, for sure.
Okay.
Yes, for sure. We have a couple of years left in the project. And the tricky bottleneck part of it, I wanted also to go to Indonesia, but with this situation was not possible. So I even could smuggle some samples from Roy, perhaps. But maybe it's also possible to deliver it somehow else with the specific delivery. But I don't know the rules from the third countries to European Union, if they ask some specific permissions that you send, because it may be treated as hazardous waste if you deliver it by post. But if to do it in a smart way and call it like laboratory samples, I don't know, you can't mention that it's organic, because then it's another agricultural problem that they will, what is that, maybe some invasive seeds or something. So this is a technical problem at the moment. And of course, it's mainly for the scientific work. We don't work in the big scale now. This how much we can calculate how much is what inside, and perhaps write a good scientific papers. So this is what I see, of course.
So I think it can be a very fruitful collaboration. Yeah, I think Pak Roy can follow up on this. And there is also another question about plastic waste. You mentioned about the landfill too, yeah. And plastic waste is a big problem in Indonesia. Do you think that there are any best practice in Estonia which can be shared to Indonesian people and to educate, especially in terms of the education?
It's a kind of different, of course. Like in Indonesia, you have 150 million or even more. I don't know how much people, 200 million perhaps. In Estonia, it's 1.2 million, and it's not very dense populated. So we are a little bit compact. And Estonians are looking to the Scandinavian example very much, to Finland especially. So the sorting and the environmental education and awareness is the priority. And also this sorting has been put in the law, and you have these sorting centers. And even when the market goes down and the plastic has the negative price, like I think it's now also, because China and India banned the import of plastic, the price went to negative. So you need to pay someone who takes it, something like that. So it's not a benefit for enterprises. It should be also delivered in the law in some way, that someone wants to make the product from it, because no one is like NGO to work for free, and enterprise cannot work with the losses. So this is a multi-question of environmental and waste management, how to deal. And Indonesia, as far as I know, is federative country, and every federative land perhaps has different rules. So perhaps it should be both from the bottom up and from the top to down approaches. One is to educate, and for government or local government to develop this sorting rules, that it's not allowed to make it just to the somewhere, or to dig in the ground or to the ocean. And It's not easy question, I know. It takes 2-3 generations, as I was told in Switzerland when I was visiting. Yeah, they said it's 50 years approximately.
50 years. We hope that Indonesia can get 50 years, maybe. We also have another question. Bu Devi has raised hand and will ask directly. Please, Bu Devi.
Thank you very much, Ms. Nina. Good afternoon, Mr. Juris Burlakovs. Now, I would like to ask about PGA's roles as critical elements for industry in the future. So it will rise, requiring sustainable exploration, mining, and recycling. So would you like to share with us about the strategy, how to sustainable
just to be the very objective and to talk from a side, from another planet, I would say to people not consume too much and don't change the devices too much which you use in the personal life. And also a little bit of old-fashioned view that infinite technology development also is not too good, because like Apple is producing for the linear market every year a new model of telephone, and it's not possible to recycle. Even if you collect perfectly the small indium parts, which is micrograms or milligrams in this telephone, you cannot recycle. It's not possible, even if you pay from the government extra to help it. So the thing number one is to reduce the consumption when it's possible. Then to reuse. For instance, I try to reuse old things. Okay, sometimes it's not very energetically, but it's another question about energy issues and greenhouse gases and so on, how to calculate this full life cycle. And recycling technologies should be developed. Another strategic direction, the big one, is substitution. To find the technologies when you don't need, like this antimony, which will finish by 2043, for example, and platinum group elements, they are not so scarce, but the problem is that all these tiny elements, including these platinum group elements, they are used in combination. You dig out like nickel, copper, and then what is remain is the platinum group elements. And but I think this problem with platinum group elements, a lot of them will expire because Green Deal and all these directions to electric car will diminish this problem at least. They are mostly for the engines, for the catalysts used. Not only to that, but it means that a resource for that, this pool will be bigger for other smaller needs. So if you use more copper and nickel, actually you get more PGMs. Here is the geopolitical risk more about the war in somewhere, or social unrest in South Africa, where you have problems with these mining companies which doesn't pay enough money. Or it's not just environment or supply, it's also the geopolitical thing.
Okay, thank you very much.
Okay, thank you, Devi. Thank you also, Dr. Juris Burlakovs. It has been a very interesting session, and I think we learned a lot from the presentation given by Dr. Burlakovs in this session. But personally, what I can highlight is that what we can do, we can be environmentally smart consumers, yeah, and to reduce and reuse efficiently. And now this, ladies and gentlemen, this is the end of our session with Dr. Juris Burlakovs. Thank you very much, Dr. Juris, for sharing your research with us. And now, as a token of appreciation, we will relay your certificate. And ladies and gentlemen, please give applause for Dr. Juris Burlakovs. Okay, and this is your certificate. Okay. Now, ladies and gentlemen, let us immediately move on to the next speaker.